Planning on watching a scary movie on the weekend? Well, I hope you've been sleeping well, because new research has discovered that the amount of sleep you get beforehand can subsequently affect how scared you become. Researchers have looked at the sleep of participants at home and in the lab by measuring brainwave activity to understand how sleep prior to a fear learning task may be important. I'm Michael Wheeler, and I spoke to Itmar Lerner and Shreya Lupkin.
Previous research has shown that sleep, and particularly REM sleep, that is the stage of sleep where dreams appear, have effects on how memories for fear learning is consolidated, which has something to do with post-traumatic stress disorder, because we know that people that experience trauma, their sleep afterwards may affect the probability of them developing a full post-traumatic stress disorder later on. We were trying to see whether regular day-to-day sleep before fear learning could have an effect on the initial encoding of fear learning while they were exposed to the fear memory.
Okay, great. And Shreya, how did you go about investigating this question?
Sure. So we actually conducted 2 experiments to answer this question. The first experiment, we used a combination of unobtrusive sleep monitoring devices, so a headband that monitored brain waves, a bracelet that monitored arm movements, and we just sent people home and had them sleep normally for about a week. When the week was up, we conducted a fear conditioning experiment inside of an MRI machine. So we were monitoring what was happening in their brain while they were learning to associate some sort of neutral stimulus with a mild electric shock. In the second experiment, it was a very similar paradigm in that we also had people sleep and then did a conditioning experiment in an MRI machine. However, instead of using our unobtrusive sleep monitoring devices for about a week, we used traditional polysomnography for a single night. Polysomnography would be the industry standard for this type of experiment.
And so, Itmar, what was it that you found?
So what we found was that the more REM sleep subjects had over the course of a week, on average, the less the activity was in brain regions related to fear learning during the acquisition of the fear memory.
One way to think about it is that when the subjects were going through the fear learning task, the fact that there was less connectivity between the amygdala, which is the fear center of the brain, and the hippocampus, which is known for memory formation, would suggest that the memory was being coded perhaps with less emotional tone to it. So the memory was being recalled, but with less fear.
Shreya, I'm wondering whether there's a difference between the type of fear learning that can lead to post-traumatic stress disorder, which could be deemed negative, and the positive type of fear learning that might help you learn how to drive safely in traffic, for example. And would you expect that increased rapid eye movement stage sleep would lead to a decrease in subsequent fear learning in both a positive and a negative context?
So I don't think you would say that REM sleep would cause you to not learn fear well when you need to. We're saying more that we think that it may prevent this enhancement of the fear itself while you're encoding it, so that you end up generalizing it to a much broader and less adaptive sense.
And it is believed that REM sleep may be resetting the amygdala, which is, as we said, the fear learning center of the brain, and allowing it to have more appropriate and accurate responses to fear the next day. So it kind of creates a clean slate, and that's how REM may allow to reach this sweet spot of fearing the right things, but not overgeneralizing them and being sensitive to too many things over the course of life.
So there may be nothing to fear but fear itself and lack of sleep. That was Itmar Lerner and Shreya Lupkin from Rutgers University, and their work was published in the Journal of Neuroscience.